Okay, so now we're on page 443. We are on 13.3, which is power. Power, again, is basically work per second, work per hour, work per whatever it is. Okay, so it's going to be time, work, where work was basically force times distance, right? Force times distance over time. Okay, so 13.9, so, okay. So think of it as this. Power, the requirement, power of requirement is how quickly do you want to do the work? Okay, does it take more power to run up 3 steps of, I don't know, a staircase? Or does it take more power to walk up?
Takes more power to walk.
Huh?
Takes more power to walk
Takes more power to walk.
because it's longer.
What's longer? The time's longer, right? So you're going to do the same amount of work. You're doing the same amount of work. So if it takes a longer time, that means it requires less power,
Oh, really?
right? So it takes less power to walk up the stairs than run up. Does that make sense?
Yeah.
Because if you look at the thing, where it says time, the number gets bigger, so it makes it
Yeah.
overall.
So it's kind of like when they talk about the muscle cars, right? They talk about muscle cars. It says
There's muscle.
it takes well, I don't know what 6 point so many seconds to go from 0 to 60,
Those horsepower.
right? Versus if you are driving a Pinto, it takes, I don't know, 12 seconds.
Horsepower is torques per second.
So how much which one requires more power?
Torques per RPM, there we go.
You'll be what?
Huh?
Which one takes more power?
What the first one was?
The first one, right? Because it takes, you want to do the same amount of thing, but you're taking less amount of time, right? Does that make sense?
So the muscle car uses less power?
No, it requires more power.
Yeah, because they go through like.
They do the same work because they're going from 0 to 60. One takes 6 seconds, the other one takes 60 seconds. I don't know.
So basically, less time means more power.
Correct.
What about weight? Doesn't weight matter?
Weight.
Well, it has to do with force, right?
Weight. Okay, so what is work? What is the work done here?
The amount of force you're applying over a distance.
No. Let's just talk about the cars.
Oh,
Okay, so we're talking about the cars. So are we changing any potential energy here?
no.
We're just changing the kinetic energy, right?
Yeah.
So kinetic energy is expressed in this way, right?
Yep.
So the larger the mass, the heavier, right?
Mhm.
The more mass, since we're on Earth, and the force is going to be mg, right?
Mhm.
Okay, so the larger, the more heavier, right? The more heavier, it's going to require, because it'll take more power too, right? Because you're going to do more work,
Yeah.
right? But I don't know what the difference between a Mustang and a Pinto is. Is that what
It's like 2,000 pounds.
2,000 pounds difference?
Yeah.
The difference is?
Yeah.
Well, that's a lot.
Mustangs are not like cars.
That's
Huh?
a lot. That's
They're
very
like
specific.
3,500 pounds.
Okay. All right. Well, I don't know. So that's a lot less
I
than
know, right?
Yeah.
So if you have twice, is that like twice the amount of a Pinto?
Yeah. It's all on that.
Okay. All right. Anyway, so again, so that's what we're looking at. Okay, we're looking at the work divided by the time. Okay.
I'm not
So
sure.
let's say that we have.
I think my
Let's say that we have
You don't drive
let's go, okay, we talked about that, flip the page, let's go to 444. We have the power is equal to work divided by time, so in the SI units, your force is going to be newtons. This is Newton meter divided by second. A Newton meter is what?
Joules.
It's a joule, right? And this is going to be a watt. Okay? A watt is a fairly small unit. You're usually going to deal with kilowatts or megawatts. Okay, a watt is a pretty small unit. In your British unit, what are we talking about? British unit, we're talking about what?
That's a good question, Mr. Allen.
This is going to be what? Huh?
Isn't it horsepower?
It's
Pound?
pound force, right? Isn't it pound force? Pound force times this is feet per second.
I
Okay?
hope I never have to use British units.
So what is this? Pound force times foot. That's going to be so they're just going to call this just there's this.
It's
So
just
we're going to
a
go straight to a
pound
watt here. We're going to go into a watt, but there's a difference there. Okay? So this is going to be equal to one of these is one of these is one of these, but this is not 1 watt. This is 1.36 watts. Okay? Now here's the horsepower that you were looking for. 1 horsepower is about 745, I think. 1 horsepower is 745 watts. Okay.
To clear the misconception in my head, what actually is horsepower? It's not just
Torque.
how much a horse can carry, right?
Horsepower is
Is it?
no,
No, it's not.
no, it's
Why
not.
is it called that then?
I have no idea.
It has nothing to do
I
with
think
horses.
it's just because it's like, it's used often in cars, and before cars it was horses, so I think it just like,
How much?
as a-
Google it. Somebody Google it right
How
now.
much horsepower does a horse have?
Tell me what the origin of a horsepower is. What does a horsepower mean?
Is a pregnant horse 2
Well,
horsepower?
a horsepower
Do
is
not.
horsepower.
No, why is it called that?
What? Okay.
It's invented
Not
by
like
the
what it
engineer
is, it's
James
like-
Watt. The story goes that Watt was working with ponies lifting coal at a coal mine, and he wanted a way to talk about the power available
I
to
was
these
right.
animals.
Okay, we good?
So then a pregnant horse has 2 horsepower.
I'm like a horsepower, because it's not fully developed.
Okay, so that's basically it. Now let's go there. There are several examples here. They're all kind of the same. So let's go ahead and do the example 13.8 on page 446. Let's see if we can go through this.
More horsepower. Jesus.
Okay, so on 13.8, so page 446, determine the power required to move an object that weighs 800 newtons a vertical distance of 4 meters in 2 seconds. So we're looking at power, which is work, right, divided by this. So how much work did I need to do? I have 800 newtons, right? Is it 800 newtons?
Yeah.
800 newtons, and I'm going to lift this how many meters?
4 meters up.
4 meters, right? Up, right? Obviously, because when I'm going down, this is where you do the work, because you're working against gravity here, right? And how many seconds does this take?
2.
2 seconds. We know that a newton meter per second is a watt. Okay, and we want to express this in horsepower. Okay, horsepower is what?
135 watts.
So it's gonna, if I divide this, so I'm gonna get 1 horsepower was 745 watts, and so 0.7 kilowatts, if you will,
Man, that's a lot
Right.
of work.
divided, like a little over 2, 2.14. Pretty simple. Ain't nothing much going on there. And then I'll leave you guys with the rest. I don't want to take away your joy in going through those.